Have you ever wondered if we're just passive observers in the universe or something more? There's a famous experiment in quantum physics, the double-slit experiment, that some say proves we literally create reality with our minds. It's a claim that blurs the line between science and spirituality, starting with a simple setup that produces a result so strange, it baffled even Einstein. So does our awareness shape the world? Let's separate the science from the speculation. Imagine a machine firing electrons one by one at a barrier with two vertical slits. Behind it, a screen lights up where each electron hits. If you close one slit, you get a single band on the screen right behind the open one. Close that slit and open the other, you get another single band. No surprises. So, logically, if you open both slits, you should expect to see just two distinct bands, right? One for each slit. But this is where reality takes an unbelievable turn. Instead of two bands, what appears is a complex interference pattern, a series of many bright and dark bands. This is exactly what you'd see if waves, not particles, were passing through the slits. Think of dropping two pebbles into a still pond. The ripples spread out, and where the crests of the waves meet, they amplify each other. Where a crest meets a trough, they cancel out. This pattern is a hallmark of wave behavior. But we were firing individual electrons, which we think of as particles. How could a single electron, fired one at a time, create a wave pattern? It's as if each electron somehow passed through both slits simultaneously, interfered with itself, and then landed on the screen. This is the core mystery. The electron leaves the source as a particle, behaves like a wave to pass through the slits, and lands on the screen as a particle again. In this wave-like state, it's not in one single place. It exists in a cloud of possibilities, a state physicists call superposition. This result is so bizarre that scientists decided to peek. They placed a detector right at the slits to find out which path each electron was actually taking. This act of measurement, of gathering information, should have just satisfied their curiosity. Instead, it changed everything. The moment the detectors were turned on, the interference pattern vanished. Gone. In its place were the two simple bands we originally expected. The very act of observing which slit the electron went through forced it to choose a path. It stopped behaving like a wave of possibilities and started acting like a well-behaved particle again. This is what's known as the observer effect. The wave of potential outcomes collapses into a single, definite reality the instant it's measured. And this is where the most popular and most misunderstood interpretation comes from. The idea that a conscious observer, a person watching, is what causes the collapse. It's a captivating thought, that our awareness is the force that turns fuzzy quantum probabilities into concrete reality. But is that what's really happening? Well, not exactly. In physics, the word observer or measurement doesn't mean a person with a mind. It means any physical interaction at all. The detector at the slits has to interact with the electron to find out where it is, perhaps by bouncing a photon off it. That interaction is the measurement. It doesn't matter if a scientist ever looks at the data. The physical disturbance itself is what breaks the delicate wave-like state. The mainstream scientific explanation is a concept called quantum decoherence. Think of the electron's wave of possibility as a perfect, fragile ripple on a pond. As long as it's isolated, it can create that interference pattern. But the universe is a noisy place. The moment that electron interacts with anything, a photon from a detector, an air molecule, it's like touching the surface of the pond. That touch sends out chaotic vibrations that overwhelm the original ripple. The information about the electron's wave-like state leaks out into the environment and gets scrambled. Its superposition is destroyed. It's no longer in many possible states. It's now in one definite state. So it's not a mysterious mind link, but a physical process of information transfer. Now, even with decoherence, physicists don't all agree on what it ultimately means. There are several competing interpretations. The Copenhagen interpretation says a particle simply exists as a wave of probabilities until measured, at which point the wave collapses. It doesn't explain why, it just says it does. Then there's the many worlds interpretation, which proposes the wave function never collapses at all. Instead, every possible outcome actually happens, each in its own separate parallel universe. So when you measure the electron, the universe splits. In one universe, you see it go left. In another, you see it go right. And newer ideas like cubism suggest the wave function doesn't describe the particle, but rather the beliefs of the observer. For a cubist, the collapse is simply the observer updating their beliefs with new information. None of these are proven. They are philosophical frameworks for making sense of the same bizarre results. So, where does this leave the idea of consciousness and intention? While the mainstream view is that a non-conscious detector is enough to cause collapse, some have explored whether focused human intention can influence quantum systems. Experiments where people try to mentally influence random number generators have produced mixed, controversial results and are far from being accepted by the scientific community. There is no conclusive evidence that our minds can directly alter physical reality. And while the philosophical debates continue, these principles are the foundation of transformative technologies. Quantum computing harnesses superposition to perform calculations impossible for classical computers. Quantum cryptography uses the observer effect to create unhackable communication. If an eavesdropper tries to observe the data, the very act of doing so changes it, revealing their presence. From ultra-sensitive medical sensors to new materials, our understanding of this strange quantum behavior is driving real-world innovation. So, the double-slit experiment doesn't prove that your mind collapses waves into particles. The observer is a physical interaction, but it does reveal a profound truth. The universe at its most fundamental level is probabilistic, uncertain, and deeply strange. Reality isn't a collection of tiny, solid billiard balls. It's a shimmering dance of potential and actuality, and our relationship with it is more participatory than we imagined. The act of asking a question of the universe is not passive. It fundamentally defines the answer we get. This forces us to reconsider our place in the cosmos. If the universe is a set of possibilities waiting for an interaction to become real, what does that make us? Are we simply complex machines causing decoherence? Or is there a deeper connection between our awareness and the fabric of existence that science has yet to uncover? What do you think? Let me know in the comments. And if you enjoy exploring these deep questions at the edge of science and understanding, follow for more.